So let's do. So yeah, after discussing the renewable energy with the other Nicola from our team, now we'll be seeing this new development we have in the energy statistics currently, which is the introduction of a new annual questionnaires in our data to collect information on hydrogen. So we'll be seeing a few key hydrogen trends to understand better why we created this new annual questionnaire, and also and then we will see the key concept around how we build the methodology to collect the data, and then we'll be presenting a few the hydrogen data reporting with a few examples from the questionnaire itself. Just before we start, just a few words. This questionnaire was developed in partnership with the European Energy Statistics Commissions, Eurostat, and we share the methodology and that same template with them. And the methodology, the notes and questionnaire is available for free on our website. You can just Google IEA hydrogen annual questionnaire, and you can find it available for download. So if you want to have a look, play a little bit with it, or if you have information in your country and you wish to share it with us, feel free to try and have a look. Now let's move to the key hydrogen trends. So I guess most of you work in the energy field. You heard about hydrogen in most of the newspaper and the new development that are happening in many countries. But why is it so important for many people? Hydrogen is seen as an important option to support the climate emissions and the reduction of CO2 emissions for many countries and many industries. And also, it's seen more and more as a good source, as an enhancement of the energy security, especially in Europe after the start of the Russian invasion of Ukraine. The dependency of natural gas was really visible for everyone. So there was a rise of need for new fuel to be used for many industries to replace the natural gas. In terms of net, so a lot of countries have pledged to reach net zero or to reduce their CO2 emissions by certain dates, 2030 or 2050. And to reach those, several have already put in place policies that are aimed to increase the capacity in terms of hydrogen production and uses, or also regarding trade and sales of hydrogen in around the world. So we have over 40 countries currently that have policies that are actually either been developed or already in place in the countries to develop those projects. There's also growing international cooperations. We see mostly in Asia and also in Europe, but there are more and more countries that are working in partnerships to try to develop production, transport, and uses of hydrogen a little bit everywhere. And also, so as I told you, this is a good source of reduction of CO2 emission, because when you burn hydrogen, what you get is water. It's still considered as greenhouse gases, but it's far less potent than CO2. So that's why it is just preferable. And at the same time, hydrogen is a very energy concentrated energy commodity, so it is useful for many high energy intensity industries. And because of all those developments and the variety of technologies and ways to produce or work on hydrogen that have been developed around the world, there was the need to develop a common methodology to collect the data and to analyze what was happening in the world. So hence this new questionnaire that we have been developing. In terms of rising demand, right now the demand is between 90 to 100 million tons of hydrogen per year in the world, mostly in industry, in conventional industries, and in refining. Hydrogen is being used in refining to separate the sulfur from the rest of the crude oil and the oil products. And there are a lot of plans already in place to increase the demand that will increase the demand of hydrogen by 2030, including new ways, new uses for the hydrogen, reaching 130 million tons of hydrogen worldwide, and with new uses in transportation, in specific services, and in a new system such as energy storage. We'll see about that later. In terms of development, so as you can see on the left, production of hydrogen can be done by several ways, but the important part is to match all the objectives that we talked about before, is to have a green hydrogen, a clean hydrogen. And to do so, there are two main pipelines that you can use, either the electrolysis, to simplify in very big lines, you put an anode and a cathode in water and you let the electricity flow through a membrane that will separate the hydrogen from the rest of the molecules, from the molecules of water, and give you the gas. And you can also use fossil fuel with carbon capture and storage to generate it. And those two are planned also to reach the capacity of production that you can see on the left, sorry. On the right graphs, you can see that currently you only have the blue part that are operational, the yellow that are under feasibility, and the red dot is only on early stage project for development. So there's a long way to go, and most of those technologies are just being developed or being considered by many countries. So this is why also we wanted to have data early to see what was actually feasible and what was actually producing enough to meet the demand. The growth in electrolyzers, though, is actually real, and it's actually happening right now. As you can see on the left, in just 4 years, we multiply by at least four times the capacities of electrolyzers in the world, and this is driven by China, who installed a lot of new plant and potent big projects that actually produce a lot of hydrogen to match some demand that they have for new transportation system and some of their high energy intensity industries, such as iron and steel. And so as you can see on the left, so you see the same graph on the stage at which are the projects right now. And on the far right, you can see also the type of capacities that you were expecting, and you were expecting to see. We need much more bigger electrolyzers to meet the expected demand if we match the policies that are in place right now. So again, to show you to show that this is actually worldwide development. Those are the committed current electrolyzer project, and it's mostly concentrated in Europe, China, and so OECD, roughly. And for now, we have potentially 14 gigawatts installed of electricity. The announced project by 2030 is expected to be 420 gigawatts. So that's quite a lot. That's a big development for the next 6 years. And that will be actually developed in many different countries. You can see Morocco has a lot of big projects coming up. You have Egypt, Australia that has a lot of interest also in those parts. So those are expected to be important for every country all around the world. And again, if we check by regions the manufacturing capacities, we can see that actually the development is again spread on various different areas of the world. Even if China will occupy a big bulk of this increased demand, as it is foreseen for now. I see several questions. Maybe are there any of interest? I think Luca should be in the chat right now. Let me check.
Yeah, there are no questions so far.
Okay, thanks. So let's keep going. If that's okay. And finally, to finish with the current trends in hydrogen, so there are still several barriers that remains regarding the development of hydrogen. First of all, it's the investment part, because many countries have put in place policies and projects, but the money, the funds are not there yet. And also there are a lot of technical difficulties especially regarding the transport and facilities to move and manipulate the hydrogen. As we will see in a few seconds, hydrogen is not an easy gas to work with. So we need specific development, specific industries to be put in place so that we can progress on this. So we move to key concepts regarding hydrogen. So hydrogen, or technically it should be dihydrogen, but we use hydrogen to ease life for everyone. It's a gas, it's odorless, non-toxic, but the issue is that it's highly combustible. It is not a very stable gas, and it will react easily with many other elements, especially if you leave it in the air, but you might quickly end up with a big explosion. So hence the difficulties in terms of structures and industries to work with that kind of gas. In our data, we consider it as a derived or secondary product, like any oil product that you will be hearing about in the coming presentation tomorrow or Wednesday. And to measure it, we use the terajoules, such as like for natural gas and for many gases. It's easier for us to work directly with the energy units than with mass or volumes, because it depends on the physical conditions at which you measure it. If you want an approximation of the calorific value of hydrogen, 140 megajoule per kilogram of gas is roughly a good approach, which, as I put that, is 3 times the energy content of gasoline. So that show again the potence of this fuel and its interest for many industries. We will be considering here gas purity that are at least 98%. It's just because also after discussion with our analysts and several industrial, that most of the time, if you use hydrogen as an energy commodity, it will be almost pure element, because it's not that stable. So if you let impurities in that, you will lose quickly any interest to use that gas. So just consider that we are focusing here on a pure gas of hydrogen, or almost pure. We cover international production and byproducts, meaning that we be interested in companies in structure that produce hydrogen per se, or refineries that will be producing hydrogen as a byproduct of their general normal activities. Also, we try to cover everything that is happening within plants, meaning that, again, in the case of refineries, they produce hydrogen and they use it in specific activities within the refinery. We'll be trying to cover those. It's a development we want to cover, to have a better coverage of the refining and also of the petrochemical sector. We'll come into this just after. And also we avoid in the data to talk about clean hydrogen, green hydrogen, pink hydrogen. We do not use those classification. We talk about the gas, because of its chemical composition, and we'll be having different flows to identify the sources, and that's what can be used later on. Also, we try to avoid covering hydrogen present in other compounds. If it's like present in a specific gas, natural gas, we have trace of hydrogen, we do not focus on that. But we have 2 categories that we will also be covering in this questionnaire because of their interaction with the hydrogen production and industries, and also because of their growing importance potentially in the energy commodity world. Those are ammonia, which for now is mostly used as a non-energy commodity for fertilizers and specific chemical reactions, but it's totally derived from the hydrogen production lines and can be used as a transport commodity for hydrogen. It is considered in several projects to be used as a transitional state for the hydrogen to be safely shipped from one part to another. And it is something that many people raise interest for, so we try to cover even if it is mostly for non-energy uses. And the last part is what we call the e-fuel or electrofuels. Those regroup a lot of new development, new technologies, new type of energy commodity that are not easily defined because it's a lot of different ways. Roughly, the idea is to use hydrogen and specific gas, such as carbon monoxide or dioxide, to create a new fuel. So those are fuel that are not that the RFNBO that you might see in some place is for non-renewable. Sorry, let me see again the definition. It's a mouthful. Renewable liquids and gaseous fuel of non-biological origin. So those are all liquid and gas that are derived from specific chemicals, and using hydrogen, you can generate a new type of energy commodity that can be used. So those are like almost always include with some part of hydrogen production lines, and those are a lot of small developing projects a little bit everywhere in the world. So this is a category that is a little bit more difficult to understand, so do not spend too much time on it, just know that this is a category that we try to collect here. In terms of how we will be working for the data in balances, it will be following roughly what is done for the rest of the fuel. So we have a supply part where we include all the production from electrolysis, or the production derived from other energy commodity. So that includes, of course, refining natural gas and also some of the coal activities from which we can extract hydrogen. And also you will have there the trade, the bunkering, and the stock changes for the countries. And then we have the demand part that will include the transformation of hydrogen into some other commodities, the consumption within the energy sector, and the final consumption. We'll be here covering transport industries, other sectors, and the energy and non-energy use, especially, will have a far more bigger importance than for the rest of the fuel, because of all the interaction that you can have with non-energy use sectors. So in terms of production, we can get hydrogen from different other categories of energy commodities. We can have from natural gas, oil products, from coal, and from also renewables and non-renewable waste. So all those technologies we are covering in the questionnaire, and we distinguish also the production from those sources that are with or without carbon capture storage, to again try to identify which part is emitting the less possible CO2 in its production, because the whole hydrogen as a green so product is very important for a lot of policies and analysis. In production, we also have the production from electrolysis. As I told you, electricity input into a tank of water. So we distinguish here the electrolysis, the sources of electricity used in this process, which means that if you input the grid electricity, or if you are directly connected to renewable sources, such as, for example, you have a solar plant, and you are producing a lot of electricity and you want to safeguard a bit of it as a storage, you can have an electrolyzer to produce hydrogen, which could be used as a storage of that energy for later when the demand is actually matching. So we distinguish here the renewables, the nuclear, the fossil fuel sources that are directly connected to the electrolyzers, and also if you have specific electricity production that we do not cover, we have an other category. Yeah. So ammonia and for ammonia and for e-fuels, that will be closer to what you have in the rest of the annual questionnaires. So we'll be reporting the quantities produced from other energy sources, and some specific flows that could be matching for them. And keeping in mind that, for example, in case of ammonia, 80% of it comes from natural gas. So that's where we expect to see, of course, the biggest share. We have trade. So for now, the trade of hydrogen as a gas is, of course, currently done mostly by pipelines, so inject or blended with other gases. And also we have other transportation system, such as the transformation into ammonia and methyl cyclohexane, that can be used as chemical transport vectors for the gas to go then somewhere else. Of course, if you have transformation losses, we also need to know, because that's accountability and also understanding what's happening in terms of transport and the efficiency of transport. And now we leave the supply part to go to the transformation. So hydrogen can be used as a combustible to produce electricity. Also, it can be used in gas work and gasification plants to be converted into gas. And also, as we saw, it can be used to produce ammonia or e-fuels. But all of those are covered in the transformation part in the annual questionnaire. Also, in the transformation part, we have a big part regarding refinery outputs, because hydrogen is mostly from producing as refinery byproducts, and it is totally linked to those activities. All right, so for the last part, we go quickly through the current stage of the annual questionnaire. Again, this is a work in development. The first version is online, and we collect on a voluntary basis the data that our contacts can provide. And it's divided in 6 tables. So the first part covers the supply with production and stocks. The second part, table 3 and 4, are for consumption in transformation, energy sector on use, and final consumptions. We have a specific table for trade, and finally the infrastructure with some capacities. So this questionnaire is deeply linked with the other annual questionnaire that we publish. So what we have in the indigenous productions as value should match what we have in some inputs to transformation in the other questionnaires. For example, the production from refineries should be matching the other hydrocarbons produced in the other questionnaire. Or we could have the input of electricity into electrolysis that should match what we see between the electricity questionnaires and the hydrogen questionnaire. Also, we should have a connection and matching values between the transformation sectors and the old questionnaire for the refining end. And here is how it looks for now. So you can, as I was describing you have different lines by type of productions. So you have from natural gas without carbon capture and storage, or with carbon capture and storage, and the detail for the electrolysis also. And we have a last part from other source that should cover any new technologies that we did not foresee when we were preparing this annual questionnaire. You have then here a view of the transformation energy sector on use. It's really looking like what you will see in many other annual questionnaires, so it's not worth spending too much time here. Only one part that is a little bit different, but we cover the transformation losses. The transformation losses specifically in the refineries, and also the transport losses. So those are 3 types of losses that we try to cover here to really have a view on what's happening and where the losses are. Final consumption, so we distinguish, as I told you, energy and non-energy uses, and we try to have a global view of what is happening here. And those are for the 3 main categories, so hydrogen, ammonia, and e-fuel. We don't have a slide for the last part on trade, because just the amount that is exported from one part to the other. Just note that as for any fossil fuel, we focus on the ultimate destination or the first point of origin. We do not cover transition of the energy commodity in between countries to keep things clean. And also we have the table on capacities that include the electric capacity of the electrolyzers and the nameplate capacities for production of hydrogen in specific plants. So just to have a view on what are the efficiency and the load of those plants once they are running. You will see those slides also. We have a lot of different things that are available for free on our website. Please have a look. And as I told you, if you are curious, the questionnaire is also available. You can go and test it and tell us if you have data. I'm always happy to receive them and try to make sense if